Okay, let's continue looking at the concept of limiting reactant. This is kind of combining pictures and a balanced chemical equation here. So this is a single replacement reaction with solid lead replacing the hydrogen in HCl or hydrochloric acid. And you can see I have pictures here with circles representing atoms, or in this case, you can think of them as like moles, right, of each reactant. So we're starting with 6 moles of lead and 6 moles of hydrochloric acid. And then we can see at the beginning we have none of the products, right? At the beginning we have no products. We can see this table, right? This row says before, because this is what we have before the reaction begins. I have 6 moles of lead and 6 moles of HCl. And then as the reaction takes place, right, we're going to use up some lead and we're going to use up some HCl. Which one runs out first? Well, if I look afterwards, notice that there's none. There's no HCl after. That's how I know, right, that HCl is the limiting reactant, because it ran out first. That's the definition of the limiting reactant, right? How do I know that it's the limiting reactant? You can literally look at it, right, afterwards and see there's none left, okay? We're going to learn, how to figure that out without looking at a picture in a moment. How about this question? How much HCl would you need to use up all of the lead? That's stoichiometry, because I'm saying that I am starting with 6 moles of lead. And according to the balanced chemical equation, I would need 2 moles of HCl to react with every 1 mole of lead, right? That's a simple stoichiometry problem. That tells me that I would have needed 12 moles of HCl to use up all my lead. And look at how many moles of HCl I had. I only had 6. So it makes sense, right, that I would not be able to use up all of my lead, because the HCl, I needed 12 moles to use up all the lead, and I didn't have that. I only had 6 moles. So the 6 moles got all used up. And you can see what happened. Well, 3 of these lead became part of the products here, right? Look at the 6 gray. Those are the CLs, right? That became part of these products. And then the other 6 little white circles became the 6 hydrogen gas, atoms, or 3 moles of hydrogen gas, I should say. And then this is one of the reasons why these BCA charts can be so useful, is because they really show us that if I look at the number of circles, right, before and the number of circles after, they're the same number, right? We've just rearranged them in different way. And we've learned this. We've called that the conservation of mass, or the conservation of matter. And if I actually take and, figure out, well, how many grams would 6 moles of lead weigh, right? So I could figure that out, and my 6 moles of lead and my 6 moles of HCl would have a total mass of 1,461 grams. And then after the reaction, right, I would still have 3 moles of lead left over, but this would be my 3 moles of PbCl2 and 3 moles of hydrogen gas. And that added together is the same mass, because I didn't lose any atoms, no atoms just appeared, right? So the mass before should equal the mass after. Okay, the next example here is another BCA chart, but this time I haven't filled in much. We're going to fill it in together. So let's fill it in. So before, let's look at this picture here. This tells me how many hydrogen H2, those are the green ones, how many, sorry, that's not the green ones, they're the white ones. How many of those do I have? And I just count them, right? And there's 6 of them. And the green are the chlorine, and there's 4 of them. And how many HCl's are there? Well, there's none, right? And then if I look at afterwards, right, if I fill this in, what do I have left? Well, it looks like I still have, right, 2 hydrogen molecules, okay? And how many molecules of chlorine do I have? Just green chlorines together. Well, that's none. And how many HCl's do I have? Well, that would be 8. How did we get there, right? That's what this middle row is. It's the change, right? So this tells us, right, which one, or what did each of these change by? And if I look, I started with 4 chlorine, and 4 chlorine must have reacted in order to give us 0. Notice the coefficients of hydrogen and chlorine are both 1. So if 4 chlorine reacted, it must mean that 4 hydrogen molecules also reacted. That makes sense. That's why we have 2 left over. And then look at this last one. If I start with 0 HCl and I end with 8, I must have gained 8. How do I know that? Well, if 4 chlorine reacted, and look at the balanced chemical equation, for every 1 mole of chlorine, I make 2 moles of HCl. Look at those coefficients. That makes sense that this guy would have gone up by 8. Okay? So we can see how when one of them runs out, it must mean that that was all used up, and then we can use the mole ratios, the coefficients, to figure out how much everything else has changed. We got one more example with this. So let's count here. Before the reaction started, the white are the hydrogen, and there are 10 hydrogen molecules. There are 7 red oxygen molecules, and there are no water. Now let's see if we can figure out this after row without counting it, figure out which one is going to run out first. Well, if I was to use up all 10 hydrogen molecules, how many oxygen molecules would I need to use? Okay, so if I were to use all 10 hydrogen, I would need to use 5 oxygen molecules. Can I do that? Yeah, because if I start with 7 and I use 5, I will have 2 left over. So that would mean that afterwards I would have 0 hydrogen molecules. I would have 2 oxygen molecules left over. And if I used 10 hydrogen, look at the coefficients from the balanced chemical equation. For every 2 hydrogen, I would make 2 water molecules. So this would give me 10 water molecules. Look at what's in here. Yeah, that's exactly what happened. But let's also look at why it couldn't have been the other way. Why couldn't I have used up all of my oxygen? Okay, so let's say, we're going to make this in a different color here. Let's say I used up all 7 oxygen. Well, then how much hydrogen would I have to use? So if I used 7 oxygen, according to the balanced chemical equation, 1 oxygen would use 2 hydrogen. That would mean that I would need to use 14 hydrogen. But I couldn't have used 14 hydrogen because I only had 10. That's a way that I know that the blue was the right way to do it and the red was the wrong way to do it, because I can't have 10 minus 14 and have -4, right? I can't have less than 0 hydrogen. So the blue is the correct way of doing these.